Hi students, in last class we discussed about metals, non-metals and metalloids in the periodic table, and also we discussed about valency. In this class we will discuss about atomic radius, ionic radius and how it changes in the groups and periods. Atomic radius. Atomic radius of an element may be defined as the distance from the center of nucleus of atom to its outermost cell. Already we know every atom has nucleus and different cells. The distance between center of nucleus to outermost cell is called atomic radius. Here we can see sodium atom. There is a nucleus at the center and there is outermost cell, that is third cell, M cell. So the distance between center of nucleus to outermost cell is the atomic radius. Atomic radius of an element is not possible to measure in its isolated state. Atomic radius of the element is not possible to measure in its isolated state. In liquid state, in gaseous state, we can't measure atomic radius of the element. However, we can measure the distance between the nuclei of adjacent atoms in a solid. In a solid state, we can measure the distance between nuclei of adjacent atoms. From this, we can estimate the size of atom by assigning half of this distance to radius of the each atom. We can measure the distance between nuclei of adjacent atoms. From that, we can estimate the size of the atom or radius of the atom by assigning half of this distance. By taking half of this distance, we can measure radius of the atom. Here we can see two adjacent atoms. We can measure the distance between nuclei of adjacent atoms. Then we can take radius by taking half of the distance. Another way of estimating the size of an atom is to measure the distance between the two atoms in covalent molecules. When two atoms form covalent bond, when two similar atoms form covalent bond, then we can measure the size of an atom in the similar way. The size of hydrogen atom is estimated by measuring the length of the covalent bond between two hydrogen atoms in hydrogen molecule. Here we can see hydrogen molecule. There is a covalent bond between two hydrogen atoms. Then we can estimate the size of the hydrogen by measuring the length of the covalent bond between two hydrogen atoms. Then we will take the half of this distance is taken as atomic radius, which is called as covalent radius of hydrogen atom. Here there is a covalent bond between two hydrogen atoms, so we call that atomic radius as covalent radius. If there is a ionic bond, we will call that atomic radius as ionic radius. Atomic radius is measured in picometers. It is represented by small pm. Atomic radius is measured in picometers. 1 picometer is equal to 10 power minus 12 meters. This is very important value. 1 picometer is equal to 10 power minus 12 meters. Now we will discuss variation of atomic radii in group. Here remember, radius is singular word and radii is the plural word. Nucleus is singular word. Nuclei is the plural word. Here we will discuss variation of atomic radii in group. Atomic radii increases from top to bottom in a group of the periodic table. Already we discussed in periodic table there are vertical columns. Those are called groups. If you observe from top to bottom, atomic radius will increase. As we go down in a group, the atomic number of element increases. As we go down in a group, atomic number of the element increases. As the number of cells in a group from top to bottom increases, the distance between the nucleus and outer cell of the atom increases. As the atomic number increases, number of cells from top to bottom, number of cells present in that element increases. So, from top to bottom, atomic radius increases. Hence, the atomic size increases with atomic number when we go down the group. When we go down the group from top to bottom, we can observe atomic size increases. Because from top to bottom, atomic number increases. As the atomic number increases, number of cells increases. As the number of cells increases, the distance between nuclei and outer cell increases. So, in a group from top to bottom, atomic radius increases. Here we can see first A group elements. Lithium, sodium, potassium, rubidium, cesium, francium. These are the first A group elements. Lithium contain 2 cells, K cell, L cell. Sodium contain 3 cells, K cell, L cell, M cell. Potassium contain 4 cells, K cell, L cell, M cell, N cell. So from top to bottom, atomic number increases and number of cells present in the atom increases. So from top to bottom, atomic radius increases. From lithium to sodium, sodium to potassium, potassium to rubidium, rubidium to cesium, cesium to francium, atomic radius increases. So final our conclusion is, in a group from top to bottom, atomic radius increases. Here we can see all the group elements from first A to 8th A. We can observe from top to bottom, atomic radius increases. In a group from top to bottom, atomic radius increases. Now go for periods. Variation of atomic radii in period. Atomic radii of elements decreases across a period from left to right. In a period from left to right, atomic radii of elements decreases. Why it decreases? As we go to right, from left to right, electrons enter into the same main cell or even inner cells in case of D block and F block elements. As we go from left to right, electrons enter into same main cell. If you observe D block elements and P block elements, electron enter into inner cells. Therefore, there should be no change in distance between nucleus and outer cell. As we go from left to right, in periodic table, electrons enter into same main cell. That's why there is no change in distance between nucleus and outer cell. But nuclear charge increases because of the increase in atomic number of elements. As the atomic number of elements increases, nuclear charge increases. So here we can see carbon, nitrogen, oxygen, fluorine, neon. They belongs to second period. As we go from left to right, differentiating electron enter into same main cell. Carbon contain 2 cells. In second cell it contains 4 electrons. Nitrogen it contains 5 electrons in second cell. Oxygen it contains 6 electrons in second cell. Fluorine it contains 7 electrons in second cell. Neon it contains 8 electrons in second cell. So we can say that electron enter into same main cell. Hence the nuclear attraction on the outer cell electrons increases. In a period from left to right, nuclear attraction on the outer cell electrons increases. As a result, the size of the atom decreases. In a period from left to right, atomic radius decreases. Here we can see in a period from left to right, atomic radius decreases. In a group from top to bottom, atomic radius increases. Now we will see the size of any positive ion is less than the size of its neutral atom. Remember, the size of any positive ion is less than the size of its neutral atom. For example, assume that sodium atom has lost an electron and formed a cation of sodium. Sodium contains 11 electrons. When it lost one electron, it contains 10 electrons. As proton number, sodium contains 11 protons. Sodium plus cation also contains 11 protons. Proton number is same in sodium and sodium plus. But sodium contains 11 electrons, Na plus contains 10 electrons. As proton number is more than the electrons in it. If you observe Na plus ion, it contains 11 protons, 10 electrons. So as proton number is more than electrons in it, the nucleus of sodium ion attracts outer cell electrons with strong nuclear force. Protons are present in nucleus. Electrons revolve around the nucleus. Sodium plus ion contains 11 protons, but it contains 10 electrons. So nuclear charge is more. That's why sodium plus ion size decreases. The size of any positive ion is less than the size of its neutral atom. As a result, sodium plus ion shrinks in size. Sodium plus ion shrinks in size. Therefore, the size of sodium plus ion is less than sodium atom. The size of sodium plus ion is less than the size of sodium atom. So, simply remember that the size of any positive ion is less than the size of its neutral atom. Here we can see positive ions. Group 1, group 2 and group 13 elements will form positive ions. Group 16, group 17 elements will form negative ions, anions. Group 1, group 2, group 13 elements will form positive ions, cations. Here positive ions are represented in red color. So here we can observe that compared to neutral atom, the size of the positive ions decreases. Compared to neutral atom, the size of the negative ions increases. Clearly observe this diagram. The size of the positive ion is less than its neutral atom. The size of negative ion is greater than its neutral atom. The size of any negative ion is more than the size of its neutral atom. Size of the negative ion is more than the size of its neutral atom. Example, assume that chlorine atom has gained an electron to form anion of chlorine or chloride ion. Chlorine atom gained one electron, so it forms chloride ion. Chlorine atom contains 17 electrons, 17 protons. Chloride ion contain 18 electrons, 17 protons. As the number of electrons, chloride ion contain 17 protons, 18 electrons. So number of electrons is more than the number of protons in it. The nuclear attraction is less. Number of electrons is more. Number of protons is less. Nucleus contains protons. Electrons revolve around the nucleus. So it contains less number of protons. That's why nuclear attraction is less in chloride ion when compared to chlorine atom. Therefore, the size of chlorine atom is less than the chloride ion. The size of the chloride ion increases. The size of the chlorine atom is less than the chloride ion. Arrange the following in increasing order of atomic radius. Here, you are observing one question. Carbon -4 anion, nitrogen -3 anion, oxygen -2 anion, fluorine anion or fluoride ion, neon, sodium plus cation, magnesium +2 cation. If you observe these elements, carbon -4, it contains 10 electrons. Nitrogen -3, it contains 10 electrons. Oxygen -2, it contains 10 electrons. Fluorine it contains 10 electrons. Neon, it contains 10 electrons. Sodium plus, it contains 10 electrons. Magnesium +2, it contains 10 electrons. So all they contain 10 electrons. They are called isoelectronic species. Similarly, phosphorus -3, sulfur -2, chlorine argon, potassium plus, calcium +2. If you observe these elements, all they contain 18 electrons. They also isoelectronic species. When we are arranging isoelectronic species in the increasing order of atomic radius, remember, a ion with more positive charge is lesser in size. A ion with more positive charge is lesser in size because in that ion nuclear charge is more compared to number of electrons. That's why ionic size decreases. And a ion with more negative charge is bigger in size. A ion with more negative charge is bigger in size. As the negative charge increases, nuclear charge decreases and atomic radius increases. As the positive charge increases, nuclear charge increases and atomic radius decreases. That's why when we arrange them in the increasing order of atomic radius, first of all, a element with high positive charge having lesser atomic radius. So, magnesium +2 having less atomic radius than sodium plus, they having lesser atomic radius than neutral atom neon. Then as the negative charge increases, atomic radius increases. F- less than oxygen -2, less than nitrogen -3, less than carbon -4. Remember that as the positive charge increases, atomic radius decreases. As the negative charge increases, atomic radius increases. The same way we can arrange calcium +2 having less radius than potassium plus, having less radius than argon neutral atom, and having less radius than chlorine minus chloride ion, and having less radius than sulfur -2 ion, and having less radius than phosphorus -3 ion. This is very important topic. All of you write notes and prepare well.